And number one, we're starting to look at hypothesis test. And every hypothesis test has a null and an alternative hypothesis. These are discussed in 7.1. The null hypothesis is a claim, it's kind of our baseline claim about a population value, a population mean, a population proportion, or so on. And then the alternative hypothesis will be the complement of the null hypothesis. So how they are related is that they are complements of each other, which going back to just see the options here, that means if the null is a less than or equal to, the alternative is the complete opposite of that, which would be greater than. If the null is greater than or equal to, the alternative is everything but that, which would be less than. And if the null is a statement of equality, the alternative would be not equal to. So notice one other key thing about these. The null hypothesis always has a statement of equality in it. Less than or equal to, greater than or equal to, or equal to. Every null hypothesis results in one of two decisions. We either fail to reject the null hypothesis, so we don't prove that it's true, we just don't reject it. The other conclusion we could reach is that we end up rejecting the null hypothesis. In this case, we would accept the alternative hypothesis as true. Number 3 is about type 1 and type 2 errors. And we can read more about the types of errors here at the bottom of this page. Remember, there are two possible outcomes to a hypothesis test. One is that we do not reject the null hypothesis. And that outcome could be the correct decision because the null hypothesis was true. We shouldn't reject it. But that could also be an incorrect decision. And if it's an incorrect decision, we call that a type 2 error. The other possible outcome is that we reject the null hypothesis. And again, that could be the correct decision because the null hypothesis was false. It should be rejected. But again, that could be an error. And if that's the case, we call that a type 1 error. So looking at this problem, the first thing we need to do is determine what the null and alternative hypothesis are. A furniture store claims that no more than 25% of its new customers will return to buy their next piece of furniture. So our keywords here are no more than 25%. And there's a great chart in the book that can help with setting up the null and alternative. Not more than a certain value, no more than 25%. Will give us a less than or equal to 25%. And that statement of equality always goes with the null hypothesis. So in this case, we would have a less than or equal to null, which makes our alternative a greater than. So our null is less than or equal to 25%. Type 1 error means that that is actually true. The population proportion actually is no more than 25%. But we make an error and we reject the null. That's a type 1 error. A type 2 error is that we failed to reject our null hypothesis, but we should have. In this situation, it would mean the population proportion is more than 25%, but we failed to reject this claim that it is less than or equal to 25%. Number 4, again looking at type 1 and type 2 errors, a local chess club claims that the length of time to play a game has a mean of 10 minutes or less. Other ways to say that is that the mean game time is at most 10 minutes. It's not more than 10 minutes, not longer than 10 minutes. And so we're going to get a null hypothesis of less than or equal to 10 minutes. Our alternative would be that the mean is actually greater than 10 minutes. So once we've established what the null hypothesis is, a type 1 error is when we reject the null hypothesis, but we shouldn't because it's true, which would mean that the game time actually is less than or equal to 10 minutes, but we end up rejecting the null anyway. That's a type 1 error. A type 2 error is when you fail to reject the null, but you should have because it's incorrect. In this case, that would be that the mean game time is greater than 10 minutes, and we fail to reject our null claim that it is less than or equal to 10 minutes. And number 5, we're going to set up a hypothesis test. A security expert claims that less than 10% of all homeowners have a security alarm. So our statement here is strictly less than. There is no equality. And so the claim strictly less than 10%, less than a certain value, has to be talking about our alternative hypothesis because there's no statement of equality. So we're going to get a less than for our alternative, which means the null would be the complement of that of greater than or equal to 10% as our null hypothesis. So here in symbols, the population proportion is greater than or equal to 10%, or in words, we could say it's at least 10%. The alternative in symbols, the population proportion is less than 10%, which is how we would say that in words as well, less than 10%. And whether a hypothesis test is left-tailed or right-tailed all depends upon the alternative hypothesis. And you can kind of tell by the direction the symbol is pointing. It's pointing to the left for a less than. And so this is going to be a left-tailed test. Number 6 is similar to number 5. Someone is making a claim that the standard deviation for golf scores is less than 2.8 strokes. So again, there's not a statement of equality here. We're just strictly talking about less than. And so that claim must be setting up our alternative hypothesis. With a less than, we're going to get an alternative hypothesis with a less than symbol, in this case less than 2.8. Our null hypothesis would be greater than or equal to 2.8. And so in symbols, greater than or equal to, in words, you could say it's at least 2.8 strokes. And then for the alternative, it's our claim there that it's less than 2.8 strokes, and that's how we write it in symbols with the less than symbol. Whether a hypothesis test is left-tailed or right-tailed all depends on the alternative hypothesis. And you can tell by the symbol in the alternative hypothesis, it's a less than, it's pointing to the left. This will be a left-tailed test. For number 7, we're going to determine if a claim represents the null or the alternative hypothesis. Here our claim is that the mean incubation period for the eggs of a species of bird is more than 57 days. There's not a statement of equality in this claim. It's a strictly more than, strictly greater than claim. And since it does not contain a statement of equality, it must be the alternative hypothesis. Now, for a null hypothesis, we either reject it or fail to reject it. With the alternative, we're either supporting it or we don't have enough evidence to support it. So, if we reject the null hypothesis, we determine that's not true. That is because we have found there is sufficient evidence to support the alternative, which in this case is our claim. If we fail to reject the null hypothesis, that's because from our sample data, we have found there to be insufficient evidence to support the alternative, which is our claim here. So to recap that, there are two options in a hypothesis test. And if we are rejecting the null, that means the evidence is supporting the alternative hypothesis. And if we're failing to reject the null hypothesis, the reason we don't reject it is because the evidence does not support the alternative hypothesis. And when I'm mentioning the evidence, all I'm referring to is the sample data that we have collected in order to run our hypothesis test. Number 8 is similar to number 7. We're determining if a claim represents the null or the alternative. And here we have a claim that more than 70% of households in a specific county struggle to afford basic necessities. The claim is strictly more than a certain percentage. There's not a statement of equality. And since there's not a statement of equality, it has to represent the alternative hypothesis. So remember our two possibilities. If we reject the null, it means the evidence from our sample supports the alternative. If we fail to reject the null, it means that there's not enough evidence from our sample to support the alternative hypothesis. So rejecting the null is evidence to support the alternative, which in this case is our claim. Failing to reject the null, not enough evidence to support the alternative hypothesis, which in this case the alternative is our claim. And number 9, our scenario is a pharmaceutical company thinks the standard deviation of the cost is less than a certain value. So strictly less than, not a statement of equality. When we have just less than a certain value, that's discussing or helping us set up the alternative hypothesis, which would be that it is less than that value. And our null hypothesis would then be the complement of greater than or equal to that value. So that's how we would set up our null and our alternative for this situation. And number 10, we're going to run hypothesis test from two different perspectives. Here we have a claim that the mean life of refrigerators is greater than 12 years. That's a claim by the manufacturer. So if we were representing the manufacturer here, how could we set up the null and alternative to support the claim? And recall, these are our possible outcomes in a hypothesis test. If we want to support a claim, we're talking about the alternative hypothesis. The evidence, the sample data either supports the alternative or it doesn't support the alternative. So if the manufacturer is claiming the refrigerators have a mean life greater than 12 years, we want to support that. We would make our alternative greater than 12 years, which would make our null hypothesis less than or equal to 12 years. And then we would gather our sample data, run our hypothesis test, and our hope would be that we would end up rejecting the null hypothesis, which would mean we are supporting the alternative hypothesis, supporting our claim that the mean life of the refrigerators is greater than 12 years. Now, if on the flip side, if we're actually representing the competitor and we want to reject this claim that the refrigerators have a life greater than 12 years, we reject or we fail to reject the null hypothesis. And our null hypothesis has to have a statement of equality in it. And so to include the greater than 12 years, we would make our null greater than or equal to 12 years, which would put our alternative that the mean life of the refrigerators is less than 12 years. That's how we would set up the hypothesis test, and then we would go gather our sample data and actually run the hypothesis test, and our hope is that the sample data will cause us to reject the null hypothesis, which would reject the claim then that refrigerators last more than 12 years, and would cause us to support the alternative hypothesis, which is that this manufacturer's refrigerators actually last less than 12 years.